The impending Trident-class modifications, exchanging D5 launch tubes for existing C4 launch tubes, have fueled the search for innovative processes to accomplish the work efficiently, economically, and safely. One area targeted for significant improvements is the handling and transporting of D5 ballast cans. The current method for transporting ballast cans uses a fixture which carries the can in an inclined position. This is not considered ideal since it means the center of gravity of the can is high in relation to the trailer. The result is increased towing limitations and instability during transport. This method also requires multiple intermediate steps for installing the fixture's pivot base while the can is in a horizontal position. Not all of these intermediate steps can be avoided. However, the operation can be greatly economized for lifting cans that are stored in a vertical position or being removed directly from a submarine. The overall goal of the transport redesign is twofold: to improve stability and safety while shipping the can in a horizontal position over public roadways, and to gain budget and schedule efficiencies by developing a method of lifting and moving the can to and from the shipping fixture without an intermediate laydown and without multiple intermediary lifts and equipment attachments. Stability and safety of the new design were confirmed through computer modeling and evaluation. The design of the fixture and its attachment to the trailer is based on one prime design criterion. The fixture maintains positive control of the ballast can in extreme conditions. Modifications to the fixture were designed using MSC Nastran for Windows. MSC Working Model, a motion analysis program, was also used to check the motion of the can and trailer assembly under normal working conditions and assumed impact scenarios. All of the loads applied were dynamic load approximations taken from the general specification for Trident-2 system transportation equipment. 5 working loads and 1 impact load were evaluated. The working loads represented typical expected loads during use and transport, including normal acceleration and deceleration, vertical cargo loads, and side loading. Under working loads, the smallest safety factor is 1.90 to the yield strength of the material. This means that during normal use, the fixture and trailer are 90% stronger than what is required to prevent deformation or damage to the assembly. Under the impact load, the safety factor is 1.61 to the ultimate strength of the material. In an unexpected impact, the assembly is 60% stronger than what is required to prevent any of the items from breaking away from either the fixture or the trailer. The evaluation showed that the primary objective was met. The ballast can remained attached to the fixture and the fixture to the trailer in all loading scenarios. Budget and schedule efficiencies are realized by restructuring the procedure to move ballast cans into and out of the shipping fixture with minimum handling efforts and equipment. The onloading procedure involves lifting the ballast can to the pivot base already installed on the transportation fixture. Once attached, the ballast can is laid down and secured into the saddles. This process is completed in a single series of movements, thus eliminating a number of unnecessary steps. Likewise, the offload process benefits equally from this economized procedure. Before the process began, the newly designed horizontal shipping fixture was attached to a pre-designated trailer. However, 2 former C4 missile trailers have been found to meet design requirements and are now available for full-time ballast can transport. With equipment and personnel on site, the unloading process begins. Struts on the shipping fixture are lowered to provide stability during loading. A mobile crane is used to handle the cans in the field. To accommodate minor variations in the levelness of the fixture and the bottom of the can, the pivot base is allowed to tilt slightly to match the horizontal plane of the approaching can. As the can nears its final vertical position, it is rotated to align attachment points between it and the pivot base. With the ballast can in its proper position, 4 clamps are installed to secure it to the pivot base. Once personnel are in position, the laydown process begins. Keeping the hook and handling gear vertically aligned above the can's lifting eye aids in a smooth laydown process. With the can in its horizontal position, handling gear is removed and the can is secured to the fixture. The retention bar is slid into place and secured. A turnbuckle secures the top of the can to the fixture, and trunnion cap fasteners are tightened. Once the can is secured, the struts are raised and the trailer is ready for transport. When the fixture's struts are left in place during transport, the trailer is marked as an oversized load. For long trips, the struts can be removed and carried in the fixture's built-in storage boxes, in which case oversized load signs are no longer required. For traveling with a load at highway speeds, all securing devices on the fixture are tightened to maximum design requirements per procedure. However, for a loaded fixture within the confines of a military installation, at speeds of 35 miles per hour or less, securing devices need not be torqued to the values required for highway speeds. An unloaded fixture need only have the securing devices hand tightened. These features greatly reduce both onload and offload times. Transporting the can in a horizontal position significantly improves load stability. This is particularly important over sections of steep roadway. A can in an inclined fixture may begin approaching an upright position, raising the center of gravity and increasing the likelihood of toppling. The horizontal fixture increases stability on steep roadways and improves handling on curves and at corners. During this demonstration, the loaded tractor-trailer was driven at speeds up to 65 miles per hour. The driver reported that the trailer and load handled well at all speeds and on all routes along the way. The ability to travel and handle well at highway speeds and on varied terrain yields significant time savings and adds versatility and confidence to the process. When the can reached its destination, it, the fixture, and the attachment devices are inspected for any abnormalities, and the ballast can is offloaded to a vertical storage area or directly into the submarine. The process of offloading is essentially a reversal of the onload.